So in this video, we're going to pick up where we left off with Quadratic's 2.5c, more about functions. So if you're asked to convert a quadratic function from standard form to vertex form, and remember that standard form is ax squared plus bx plus c, whereas vertex form still has an a in front, but instead it has x minus h squared plus k. If you're asked to convert from one form to the next, you're going to find the vertex first. It's easy to find the vertex from standard form using the formula. And once you know the vertex, you'll be able to write the function in vertex form using that number as h and k and using the same a value from the standard form function. So let's try doing this as part of the next example. Here's a function given to us in standard form, and it asks us first to find the axis of symmetry and the vertex. So for part A, we want to use this x equals negative b over 2a formula, which helps us to get the x value of the vertex. So we'll plug in the a and b value from this function. We'll get 12 over negative 4, which is negative 3. That's half the vertex. To get the y value of the vertex, we will have to substitute that negative 3 into the function in place of everywhere we see x. And then we'll simplify to find y. We've got positive 9 times negative 2 is negative 18 plus 36. 18 plus 7 is 25. So now we have our vertex at negative 3, 25. Vertex is a point. And then we have the axis of symmetry located at just the x coordinate of that point, written as an equation. So there's our vertex and axis of symmetry. And this actually gives us all the information we're going to need for the rest of the problem. In part B, it asks us to indicate the transformations that can be applied to y equals x squared in order to obtain this graph, so this function g of x. So y equals x squared is the parent function for all quadratics. To see the transformations, it would be helpful, as the note right here below indicates, it would be helpful if we could see it in this form, which is called vertex form, so that we can identify what the transformations were. The transformations appear here where a is, h is, and where k is. So if I could write this thing in vertex form instead, I'll be able to quickly explain what transformations happened. So to write it in vertex form, as we wrote down on the previous slide, we're going to use the same a value as in the standard form. So g of x equals the a value from the standard form is negative 2. It's still going to be negative 2 in the vertex form. And then h and k come from the vertex. So it'll be x plus 3, because we have to do the opposite, and then squared plus 25. So now I can see what the transformations are. I have 4 transformations: a negative, the 2 that's in front, the 3 that's being added, and the 25 that's being added. So all of the transformations that occur are a reflection. Remember that the negative is going to cause a reflection from the parent function, which is just x squared. A reflection over the x-axis, that's from the negative in front. The 2 in front causes this parabola to be a little bit steeper, skinnier, known as a stretch, right? So this is called a vertical stretch. That's what the 2 in front does. Vertical stretch by a factor of 2. That's what the 2 in front does. And then we have a horizontal translation. That's the sliding to the left. So horizontal translation to the left 3 units. That comes from the plus 3 that's inside the parentheses. And last but not least, vertical translation. And that's up 25 units. That's the k value. Translation up 25 units. And I should have said for the horizontal that it was 3 units to the left, because remember when it says plus 3, you actually go to the left. So that's how we are going to write this thing in vertex form and then use that to describe the transformations. And then part C says find the minimum or maximum value. So it must be talking about the function. If I go back up to the function, the minimum or maximum value of this function is going to occur at the vertex. So if it's a parabola that looks like this, it has a minimum value. And if it's a parabola that looks like this, it has a max value. So we have to check out what type of parabola we're dealing with. Because the a is negative here, we have one of these downward concave down parabolas. So we're looking for the max point. It's really easy. It's just the vertex. So if we go to the vertex, the maximum point is located at negative 3, 25, which makes the maximum value of the function 25, because the function is actually y. So the maximum function value is going to be 25. So we'll just want to write maximum value will be 25. Okay, next. One more form of a quadratic equation, this is the last form of a quadratic equation, would be if it was written in what's called intercept form, also known as factored form. And this form is over here. Again, it has an a value in front. That a value has not changed. A is the same in standard form, vertex form, or intercept form. But now, instead of having standard form written out, like ax squared plus bx plus c, this thing's been factored into two linear factors, x minus some number and x minus some other number. This is just like if we're going to actually, we'll see an example on the next slide, so I'm not going to make up numbers now. Just note that the two zeros are actually going to be here and here. Remember, zeros is another word for solutions or x-intercepts. So the p and the q are actually the two solutions to this thing if it said equals 0, right? So the vertex is going to be located halfway between them. And that should make sense for a parabola on the coordinate plane. If I have a p value and a q value, that the vertex is going to be located exactly halfway between them, or the average of p and q, p plus q divided by 2. So the vertex is going to be located by p plus q over 2, and then plug that value in to get y. And then the x-intercepts, this time we don't have to do any work because this thing is already factored. We're looking at them, right? The x-intercepts are going to be p and q. So let's see this in an example. Write the function in intercept form, and then we will sketch the graph of this function, labeling x and y intercepts. So this thing is written in standard form, but it's factorable. So if I write this in intercept form, it's going to look like this. Set up the two parentheses, figure out what the factors must be. 2x squared breaks into 2x and x. There's only so many ways I can make this -3. How about +1 and -3? I can FOIL that and double check and make sure that that indeed does equal the standard form function that I have. So this is the factored version of that, hence why it's sometimes called factored form, also known as intercept form. So I can see that my x-intercepts are going to be located at 3 over 2 and -1, right, if I set each of these equal to 0. So when I have to sketch the graph of this, labeling the x and y intercepts is pretty easy. I have an x-intercept at 3 over 2, which is 1.5. I have an x-intercept at -1. The y-intercept comes from changing these x's to 0. So if I make these be 0, then my y-intercept is at -3. And now I can connect the dots. Note that the vertex is somewhere halfway between -1 and 3 over 2. I don't actually have the vertex labeled. This point here, the y-intercept, is not the vertex. The vertex was actually just a little bit past it. But the vertex is going to be halfway between wherever your two x-intercepts are. And then the final skill that you're going to be able to do is to write the quadratic function from the graph. In this case, they want it in two forms, both the intercept form and the standard form for these two functions. If you can find the vertex straight away, that can be helpful for writing it in vertex form, but we're not even asked to write these in vertex form. So what we're going to want to do is pull out the intercepts, if we can see them, to write it in intercept form. So in part A, I can see the intercepts very clearly. Where it crosses the x-axis is here and here. So I know that my function that I'm dealing with is going to be f of x equals some a value. I don't know the a value from looking at the graph. X plus 3 and x minus 1. That's because I can see I'm dealing with a -3 and a +1 on the graph. So they must have been +3 and -1 in the function. And to figure out the a value, I'm going to need to temporarily plug in an x and a y that I haven't already used. So I can't use the -3 and the 1 that I've already used. I'm going to have to use the other point given to me, this 0, 6 right here, and temporarily plug in 0 for x and 6 for y so that I can solve for the a value. It'll be the only remaining variable. So I'm plugging in 0 for x and 6 for y, leaving me with the variable of a in front. So 6 equals a times, what is this, 3 by -1, so -3. And that gives us a value of -2. Okay, so now I've determined that the intercept form for this function, and I have to go back to f of x, right? I'm changing it back to a function. -2 as our a value, x plus 3, x minus 1. So there's the intercept form. To get this thing in standard form, you'll just FOIL it out. Right, you'll just expand this and then combine all the like terms to get it to standard form. I probably won't do that in the interest of time. And let's look at part B. They give us some slightly different information. This time they give us a very important point on a parabola, the vertex. And then they give us one other point, the point 0, 12. Let's see if that's enough information to get us somewhere. When I have the vertex, it's really easy for me to write, or at least set up, the vertex form, even though I'm not asked for that here. I could start from vertex form, which is going to be a times, remember this is x minus h squared plus k, where h and k are the vertex. A I don't know from looking at the graph, but I do know that x minus 2 plus 0, because that's the vertex. Now, because it says plus 0, I don't really need to include that. There is no k value. And again, I don't know a, so I'm going to have to temporarily replace x and y in this function so that I can solve for a. I'll use the 0, 12 point as my temporary replacement for x and y. So this time I have -2 squared, that's 4, and 12 equals a times 4. Therefore, a equals 3. So now I know that in, let's say, vertex form, this thing would look like, oops, scrolled down too far. In vertex form, this thing would look like f of x equals 3 times x minus 2 squared. And in this case, that actually is the intercept form as well, because if I wrote it out, it would actually be 3 times x minus 2 times x minus 2. And that is intercept form, so I don't need to rewrite it as that expanded version. And then, of course, to get it in standard form, I'm going to FOIL it out. And I think that we will stop it there and let you try these in your homework.